Two equal point charges q are fixed at x is equal to minus a and x is equal to plus a on the x-axis. Another point charge is placed at the origin. The change in electrical potential energy of q when it is displaced by a small amount x along the x-axis is approximately proportional to. If I say that this is q and there is another charge q, okay, placed at a and minus a, okay, that is a and a, the distance will be a and this is the origin over here. At the origin there is another charge, okay, at the origin there is another charge q placed, okay, there is another charge q placed, okay. Now it is displaced by a small amount, let us say it is displaced in the right hand side direction by a small amount x. So we have to find out the change in the potential energy. That is, we have to find out the potential energy in the first case will be equal to 1 by 4 pi, that is k. Q in the first case it will be equal to q, which is equal to q square divided by a square plus kq square divided by a square, that is due to the other charge, and potential energy in the second case will be equal to divided by a, not a square, okay, divided by a and not a square, okay. So this is the potential energy in the first case, and potential energy in the second case will be equal to k q square divided by, now the distance is a plus x, and in the second case this distance is a plus x, this distance is equal to a plus x, and this distance will be equal to a minus x, okay. So it is equal to k q square divided by a minus x, okay. The displacement is very small, so basically it will be equal to, if I find out this value, it will be equal to potential energy in the second case will be equal to k q square, okay. In the denominator we will I will take k q square common, okay. In the denominator it will be equal to a minus x, a plus x, okay, which is equal to 2a divided by a square minus x square, okay, which is equal to 2a divided by a square minus x square, okay. So now over here we have to find out the change in the potential energy, okay. So we have to find out the change in the potential energy. So change in potential energy will be equal to potential energy in the second case minus potential energy in the first case, which will be equal to k q square divided by 1 by a minus over here minus which will be equal to 2a divided by a square minus x square, which is equal to, if I cross multiply this part, it will be equal to k q square, okay, which will be equal to k q square, okay. We can divide potential energy 2 minus 1, okay. So I will take negative sign common, it will be equal to 2a square minus a square plus x square divided by a square minus x square into a, okay. This is the answer we obtain after cross multiplying, okay. This is the answer we obtain after cross multiplying. So when I cross multiply this part, okay, this will be also equal to 2 times k, okay. So 2 times a, so it will be equal to 2 times a square, okay. It will be equal to 2 times a square minus plus 2x square, okay. So when I subtract this part, it will be equal to 2a square and 2a square will get cancelled out. So it will be equal to minus k q square into 2x square divided by a into a square minus x square. Now what we will do is, since x is very small as compared to a, since x is very small, so we will approximate this value, that is a square minus x square will be approximately equal to a square, okay. A square minus x square will be approximately equal to a square. So basically this will come out to be, minus k q square into 2x square divided by a cube, okay. This will be equal to a square multiplied by a will be equal to a cube. So now rest of the terms are constant, okay. So I can say that the change in potential energy is approximately, or it is directly proportional to, I will approximate everything, okay. So it will approximately be directly, so it will be directly proportional to x square if I make the approximation that x is very small as compared to a. So the correct answer for this is, option number B, that it is directly proportional to x square.